Hello everyone and welcome once again to MJ's Maths and Stats. That's MJ Magic Studio to you. I am your host, your host, and as usual in the ghost mode, Mohit Jain. The process, the pattern we have already discussed in our first part. Link is there in the description below. Please go through it. So without wasting any time, let's start now. So the 10th part, and we are on to again numerical ability with few questions which are probables. Simple square questions, mostly from permutation combination we will do in this particular session. A question is on your screen, give it a try. Okay, let's see what we have. There are 10 indigo balls and 5 red balls. That means we have got 15 balls, out of which 10 are of same color and 5 are of same color. And these are balls. These are not human beings. That means they need to be treated as identical objects. They are placed in boxes numbered 1 to 15. It is given that one box can hold only one ball at a time. If the probability that the end box are occupied by red balls, okay, suppose this is bag number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So box number 1 and box number 15 is occupied by red balls, and that there is an odd number of indigo balls between any two balls is n by 3003, then what is the value of n? First of all, how many total cases are possible? Total cases, we have got 15 objects. That means they would be arranged in factorial in 15 ways, but out of which 10 are of same kind and 5 are of same kind. So total number of cases are factorial 15 by factorial 10 into factorial 5. That will give us 15, 14, 13, 12, 11 by 120. This goes 10, 5, 3, 5, 2, 7. So we have got 3 into 7 into 11 into 13, that is 3003. So total number of cases are 3003. Now we need to find the probability and the favorable number of cases. Just see, from box 2 to 14, there are 10 indigo balls and there are only 3 red balls. Now just try to identify that where it is possible for us to put the red balls. Can I put red ball in box number 3? Then the gap between 1 and 3 will be only one object. And it is said there should be odd number of indigo balls between two red balls. So if these two are the red balls, there is one indigo. And from 3 to 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 indigo balls. That is the trick. We can place our red ball at box number 5. At box number 7, at box number 9, at box number 11, or at box number 13. And you can see from left or from the right, the gap between any two red balls is always an odd number. If I take 1 and 9, between 1 and 9, 1, 2, 3, 4, 5, 6, 7, there would be 7 indigo balls if we are putting 1 and 9. Clear? That means for red balls, we have got 1, 2, 3, 4, 5, 6. We have got 6 places where only red balls should be placed. So in how many ways you can do this where we have identical object? It is simply 6C3. Out of 6 places, identify the 3 places and just go there and put the balls. And the remaining 10 places would be occupied by the 10 indigo balls. In how many ways? Factorial 10 by factorial 10. That is only one way. Why one way? Because all the indigo balls are identical. So favorable number of cases are 6C3, that is 20. So our probability is 20 by 3003, which is given as n by 3003. Therefore, value of n is 20. That is in option A. Raise doubts, if any, or we move on. Probability to expectation. Expectation is nothing but the mean of the probability distribution. Expectation is simply x into p. So give it a try. In a certain lottery, the prize is 1 crore and 5,000 tickets has been sold. That means probability that you will win is 1 by 5,000. What is the expectation of a man who holds 10 tickets? Expectation of a man who is holding 1 ticket is simply 1 crore into 1 by 5,000. So that comes to 2000. 2000. 2000 is the expectation of a person who is holding 1 ticket, but he is holding 10 tickets. So total expectation is rupees 20,000. Expectation means that what is the maximum average with loss and win that person can expect. Option A is the pick. Another one from probability on your screen. Give it a try. Okay, what we have? A jewelry box contains 4 red earrings, 6 blue earrings and 8 green earrings. 8 and 10, 18 total. 3 earrings are randomly drawn from the box, and it's not given that how we are drawing it, one after another or all at a time, with replacement or without replacement. In that case, we always consider that we are drawing all at a time without replacement, or one after another without replacement. In that case, total number of cases would be considered with the help of combination technique. So total number of cases would be 18C3. That is 18 into 17 into 16 by 6. So that would be 17 into 16 into 3. Now what is the probability that the earrings are different? All are different earrings. That means we need 1 of a red, 4C1, 1 from blue, 6C1, and 1 green, 8C1. These will be favorable cases divided by total number of cases. So 8C1 is 8, gone 2 times. 2 into 3 is 6, gone. 4C1 is 4 by 17. Required probability is 4 by 17. That is in option C. One of the important and favorite from TCS Digital and other company specific drive also, and this is based on independent events. We know how to solve this. Let's go do it quickly. A said classical question from independent events. In case of independent events, we know that probability of occurrence of A, B, C is given by the multiplicative effect of the individual probability, and negation is also applicable. A can hit a target 4 times in 5 shots. That means probability of A hitting the target is 4 by 5. B can hit, probability of B is 3 times out of 4, 3 by 4. And C can hit twice in 2 shots. Probability of C hitting the target is 2 by 3. As far as negation is concerned, it is 1 minus 4 by 5, 1 by 5. B not hitting the target will be 1 by 4. And C not hitting the target would be 1 by 3. Now, what is the question? When they fire together, all 3 of them are firing together, what is the probability that at least 2 shots hit the target? At least 2 shots means either 2 shots hits the target or all 3 hits the target. So, in 2 shots, we will have 3 cases. A hit the target, B hit the target, but C misses. A hits the target, B misses the target, but C hits the target. Or A misses the target, B hits the target, and C hits the target. 3 cases we will get in 2 shots being hitting. And all of them are hitting the target is A, B, C. These are the 4 cases. We need to find probability of these 4 individual cases and then add up. So what is the first one? First one is A. Let's work with only the numerator. 4 into B is 3 into C complement is 1. That gives us 12. Second case, A, 4, B complement is 1, and then C numerator is 2, that is 8. Third case, A complement is 1, B is 3, and C is 2, that gives 6. And this particular case, A, B, C, fourth one will give numerator 4 into 3 into 2, that is 24. Just find the total of that, 30, 40, 50. So the required probability is 50 by, multiply with their denominators, 3 into 5 into 4. 5 gone 10, 2, 5, 2, 2, that gives us 5 by 6. Option B is the pick. Solve different type of question based on this, because this is very regular phenomena. A classical take on permutation and combination where both should be used in tandem. Give it a try. Now, why this is classic and why we are using both combination and permutation in solving these kind of questions? How many words? Permutation, as we see, how many words, that means arrangement, can be formed by taking 4 letters at a time. That means R is 4. Out of the letters of the word mathematics. It would be a very simple NPR question if all the letters of the word, the given word, would have been different. But here all the letters of the word are not different. If it is A, B, C, D, E, F, G, H, I, J, K, I know 11 alphabets are there. From there I need to select 4 at a time to form words. Then how many words I can permute? It is 11, P4. But here all the alphabets are not different. Now let's see how many alphabets do we have. We have got 11 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 letters. But how many alphabets do we have? We have M coming 2 times. Then we have A coming twice. We have got T coming twice. Then we have H, E, I, C, S. 1, 2, 3, 4, 5, 6, 7, 8. If we look carefully, we have got only 8 alphabets, out of which 3 are coming twice. That gives us 11 letters in whole. Now here we will develop few different cases. Case number 1. If I am selecting all different alphabets. How many different alphabets do I have? I have got 8 alphabets. 1, 2, 3, 4, 5, 6, 7, 8. Out of which I need to take 4 at a time. In how many ways I can select? 8C4. Now after selection, in how many ways I can arrange them? Factorial 4 ways. Why factorial 4 ways? Because all the letters which we have selected are all different. It is simply nothing but 8P4. 8P4 is 1680. Second case, I will take 2 same letters and 2 different letters. Suppose I have taken MM and then 2 from the rest of the letters. So I have taken MMAT. Now how many words I can form with MMAT or MMHE? This is the case where in the word 2 letters are same and 2 letters are different. Now to select 2 same letters, I have 3 options with me. Either I can take both M, or I can take both A, or I can take both 3. That means out of 3 options, I need to select any one option. And once I have selected one option out of MAT, automatically I have taken 2, what do you say, letters from it. Correct? So suppose I have taken both M, then I am left with how many letters? I am left with A, T, 1, 2, 3, 4, 5, 6, 7. Now out of the remaining 7, I need to select 2. Now if you can see, we have got 4 letters with us. Clear? In how many ways you can arrange them? Factorial 4 ways, out of which 2 letters are of same type. That's why divide this by factorial 2. Let's work this out. 3C1, selection of 1 letters out of these 3 ways. 7C2, selection of 2 remaining letters from the remaining 7 letters that we have. 7 into 3 is 21. And 24 by 2 is 12. That will give us 756. Third case, I am forming words where I have got 2 same and 2 same letters. Suppose I have taken MMAA and then I am forming words. So for 2 same and 2 same, how many options do we have? We have got 3 letters option. From these 3 letters, you will select any 2. Suppose you select M and A and bring both. Bring both M and both A. Now, in how many ways you can arrange them? Factorial 4 ways, out of which 2 are of same kind. Another 2 also are of same kind. 3C2 is 3. 24 by 4 is 6. That is 18. Can we have any more cases? No. Either all are 4 different, 2 same, 2 different, or 2 same, 2 same. So total 4, 1, 6, 7, 15, 1, 7 and 7, 14, 1, 2, 4, 5, 4. How many words can be formed? 2454, 2454. Option C is the pick. Do try these kind of questions with different words and solve it. For example, you can take words like examination, very popular words, or take Mississippi, SSI, SSI, PPI, Mississippi. Clear? And do the same thing. How many words can be formed by taking 4 letters at a time from mathematics, examination, Mississippi? Proportion. This one is very popular. Proportion. And once you have done this, give us answers in the chat box, in the comment section. Thank you. We'll move forward. Classical take on probability theorems. Give it a try. Independent events A and B. If the probability that both A and B happen, means probability of A intersection B. Since A and B are independent event, it is given by PA into PB. That is equals to 1 by 30. And the probability that neither A nor B happens, A complement intersection B complement, is given by PA complement into PB complement. That is given by 2 by 3. Then find the values of PA and PB respectively. Either you can plug in the options and you can check. 2 by 5 into 1 by 12 will be 1 by 30. 1 by 5, 1 by 6 is 1 by 30. 1 by 15 and half is also 1 by 30. 3 by 10 into 1 by 9 is also 1 by 30. So if we follow this, then all the 4 options are applicable. That means we need to work out with this. PA complement means 1 minus x. Suppose PA is x into 1 minus y. That is equals to 2 by 3. Clear? If I put suppose 2 by 5, 1 minus 2 by 5 is 3 by 5 into 11 by 12 is not 2 by 3. If I put 1 by 5 and 1 by 6, 4 by 5 into 5 by 6, it gives me 2 by 3. Then 1 by 5 and 1 by 6 fits in. But if in case it is something like a theta based question where a box is given and just they have asked that what would be the value of PA or what would be the value of PB, then we need to just solve. We have got 2 equations. X into y is 1 by 30 and here it is 1 minus y minus x plus x into y is 2 by 3, or 1 plus 1 by 30 minus 2 by 3 is x plus y. If I do this 30 plus 1 minus 20 is x plus y. So it would be x plus y gives me 11 by 30 and xy is 1 by 30. Now x will be 1 by 30y, you put in here and then frame equation and solve it. But in many of the cases, if options are there, plug in the options and check it. The key, the best key here is, since x plus y 11, 30, you can feel it. 30 is 6 into 5 and this is 6 plus 5. So it automatically become 1 by 6 and 1 by 5. Which is 1 by 6 and which is 1 by 5, we don't know. But it is 1 by 5 and 1 by 6 for now. Speaking the truth, the classical question once again. You know the drill. Pause, do, and then check. Give it a try. Let's see the classical. A person is known to speak the truth 4 out of 5 times. That person will be speaking the truth is 4 by 5, and person would be not speaking the truth would be 1 minus 4 by 5, 1 by 5. He throw a die and report that it is a 5. What is the probability that it is actually a 5? He have thrown a die. suppose it is a 5 and suppose it is not a 5. Now if it is a 5, he is reporting that it is a 5. That means he is telling the truth. It is not a 5, but if he is reporting that it is a 5, that means he is telling no truth. It is not 5, it is something as 1, 2, 3, 4 or 6. And he is going and saying that it is 5. That means it is not a 5, and then he is lying or he is not telling the truth. In that case also, we need to consider the respective probability. What is the probability of getting a 5 if a die is thrown? 1 by 6, sorry. And not getting a 5 is 5 by 6. Probability of truth telling is 4 by 5. And probability of no truth telling is 1 by 5. So the probability that actually it was 5 and he have said that it is 5 is given by 1 by 6 into 4 by 5. That is 4 by 30. And it was not a 5, but he said that it is a 5, is 5 by 6 into 1 by 5. That is 5 by 30. That means the probability that he has said that it is actually a 5 is 4 by 30 plus 5 by 30. That is 9 by 30. So this is the probability that he reports that it is a 5. Now the question is, what is the probability that actually it was 5? So probability that it was actually a 5 and then a 5 was said is 4 by 30. So the probability we are looking out for is 4 by 30 divided by 9 by 30. Out of 9 cases where he have said that it was a 5, 4 were the cases where he have actually got a 5, and 5 were the cases where he have not got the 5 and he had committed crime by saying no truth. So probability is 4 by 9, that is 0.4444. That is in option A. It is like a base theorem question which I often solve using tree diagram, because tree diagram always gives a basic picture about what is happening and how to go for it. Another classic from dice rolling on your screen, give it a try. A dice is rolled 5 times. Then the probability of having a 3 upwards fewer than 3 times. We are doing an event, how many times? 5 times. What is the probability of getting a 3 when a dice is rolled once? It is 1 by 6. Let's suppose this is small p. Then q is not getting the 3. That is 1 minus p is 5 by 6. Fine. Now if we look carefully, this particular question can be dealt very simply with help of binomial distribution. Probability of x is given by ncx p to the power x q to the power n minus x. Now what is x? When a dice is rolled 5 times, you can get 0 times 3, 1 times 3, 2 times 3, 3 times 3, 4 times 3 or 5 times 3. So these are the value of x, and they are asking about probability of having 3 upwards fewer than 3 times. Fewer than 3 times means 3 would be occurring 0 time, 1 time or 2 time. We need to find the value of p0, that is nc0, 1 by 6 to the power 0 into 5 by 6 to the power 5. 5c0 is 1, this is 1. This will be 5 to the power 5 by 6 to the power 5. P1, 5c1 is 5 into 1 by 6 to the power 1 into 5 by 6 to the power 4. So that would be 5 to the power 5 upon 6 to the power 5 again. P2 is 5c2, that is 10 into 1 by 6 to the power 2 into 5 cube by 6 cube. So this is 5 cube into 10 or 5 to the power 4 into 2 divided by 6 to the power 5. If we add these three, that is the answer we are looking out for. 1 by 6 to the power 5, let it be here, We have got 5 to the power 4 common. 5 plus 5 plus 2, that is 12. 12 with 6 will go 2 times. So this we have 25, 25, 65 into, 25 into 25 is 625 into 2 by 36 into 36. 2 gone 18. So this is 625 by 36 into 18 is 648. Option B is the pick. All questions are classical, whatever TCS Digital have asked in the previous session on campus. This one is one of them. Give it a try. A pair of dice is rolled together. 36 outcomes. Till a sum of either 6 or 7 is obtained. Sum of 6 means 5 different cases. 1, 5, 2, 3, 2, 4, 3, 3, 4, 2 or 5, 1. That is the probability that you will get a sum 6 is given by 6 by 36. Or 7. For 7, we would have 5 cases. 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. Oops. 6 cases. 1, 2, 3, 4, 5, 6. For 6, we have 1, 2, 3, 4, 5. I did a mistake here. It is 5 by 36. And probability of getting total of 7 is 6 cases. When a dice is rolled, if you get a 6 or a 7, you are a winner. You will win. X denoted the probability that 7 comes before 6. Now we need to build a story on this. What will happen if 6 will come? I will win. Because a pair of dice is rolled till a sum of 6 or 7 comes. So if in first throw 6 comes, I will stop the game. But they are asking about that 7 should come before 6. Try to understand that. So my scene 1 is, I have thrown 2 dice and I have got a 7. Wow. With what probability? I have got a 7 with probability P. Suppose that is 6 by 36. Or it might happen, then when I have thrown, I have not got a 7. But if I have got a 6, I need to stop the game. That means I have to consider this. Then what will happen if in first throw I am not getting a 6 or I am not getting a 7? Clear? Not getting a 6 or not getting a 11. 11 cases. So Q in our case is 36 minus 11. That is 25 by 36. So first throw, neither we are getting 6 nor we are getting 7 with probability Q. In the second throw, we get a 7 with probability P. Or in first throw, neither we get a 7 or a 6 with probability Q. In second throw, neither will get a 6 or a 7 with probability Q. But in third throw, we get a 7 P. And this will continue like this till infinity. We look carefully. P is common. 1 plus Q is square plus Q cube. It will go till infinity. This is an infinite GP series. Summation of infinite GP series is given by A upon 1 minus R, given that mod R is less than 1. R in this case is Q, which is less than 1, and A is 1. So it is P into 1 divided by 1 minus Q. Now you can very easily put in the values. P is 6 by 36 upon 1 minus Q, 1 minus 25 by 36. That will gives you 6 by 36 minus 25 is 11. 6 by 11, 6 into 9, 54. 0.54545454. Option D is the pick. What a classic logical take now. Do give it a try. a number y is drawn arbitrarily from a set of 1, 2, 3 till 120. What is the probability that this equation is greater than 23? The total number of cases what we have is 120. Now, a number should be such that y plus 120 by y is greater than 23, and these kind of sums are always a trick which is always embedded in the question itself. Look carefully as 120 and this 23. Try to pick up two numbers such that their product is 120 and sum is 23, and hence you will get the answer. You will see that 15 into 8 is 120 and 15 plus 8 is 23. That means if I take y equals to 7, it will be 7 plus 120 by 7. 120 by 7 is how much? So that's 17. 17 plus 7 is 24. So when we put y equals to 7, we are getting a value which is greater than 23. That means when x is 1, 2, 3, 4, 5, 6, 7, all these values are greater than 23. But when you put y equals to 8, it becomes exactly equals to 23 if this is 23 number line. You're getting the value 23 when y is equals to 8. Just also find out when you will get back the value 23 again. You will get back the value 23 again when y value is 15. So when y is 8 and y is 15, 120 by 15 is 8, you are getting the value 23. But beyond that, 15, 16, 17, 18, you will get a shape curve like this. So the values from 8 to 15 will give you values which are either 23 or less than 23. So the values are 8, 9, 10, 11, 12, 13, 14 and 15. 1, 2, 3, 4, 5, 6, 7, 8. 8 values out of these 120 values will give you the value of this left hand side either 23 or less than 23. So we just need to delete it from our system. 1, 2, 3, 4, 5, 6, 7, 8. So the required probability is 120 minus 8 by 120. That is 1 minus 1 by 15, 14 by 15 into 6. If I do, it will become 84 by 90, 892, 0.93. Option C is the pick. I'll see you very soon. Keep practicing these kind of questions, and this is Mohit Jain signing off.